Hello, hello! Welcome to another wonderful day in PreCalc. Today we're going to be talking about solving inequalities. This is the last section for Unit 1. We're going to be talking about linear inequalities and absolute value inequalities. So grab those notes, put away those distractions, and here we go. We're going to talk a little bit about notation. So as a reminder, when we were talking about things on a number line, we would have less than or greater than, less than or equal to, greater than or equal to, and different things meant different symbols, had different implications on our number line when we were graphing. So, for example, our good friend less than, x is less than 3, would mean an open circle, and we want all of the values less than 3. That's one of the ways I've seen people graph. Other people go like up and over. Either way is fine, I don't care. The less than or equal to meant that we would fill in and then go less than. Greater than meant we had an open circle and then we went this way. Greater than or equal to meant we filled in the circle. So these guys here are called, this is called an open and this is called a closed. The open usually makes sense and the closed is just, well, it's not the open one. And that's how that goes. Now, when we're talking about a number line and stuff, there's other ways that we can do things. We also have something called set notation. And set notation is where these curly brackets come in that we've been talking about. We do our curly bracket and we write x such that. This is always how it goes. You've got a curly bracket. And then the next thing you put is your variable. Then you put a vertical line. So it's like half of an absolute value. Vertical line. And then over here, you put your conditions. So what is making it part of this particular set? And then you close parentheses. That's how this works. And so for your set notation, for this one, it's pretty easy. You just copy and paste your inequality over. So we have x such that x is less than or equal to 3. And then x such that x is greater than 3. And then last but not least, x such that x is greater than or equal to 3. So that's beautiful and all that fun stuff. But we also have another way that we can do things called interval notation. We had set notation, and now we have interval notation. Interval notation has opened and closed parentheses. Open parentheses or closed brackets is how these guys get referred to. So this thing here is an open parenthesis. And this guy down here is the closed bracket. So there's always a little bit of confusion when we first meet this type of notation with the interval notation, because if I tell you, hey, I want you to graph 3,7, your instinctive thing is to go, okay, well, here's x, here's y, here's 3, here's 7, and then there's a dot up there. Let's zoom in on that. So 3, 7, bada bing, bada boom. But if I'm talking about interval notation, that's not what I want you to do. I want you to go from 3 to 7, put some open circles and shade in between them. So which one do I mean when I say graph 3,7? Inside parentheses. Context is your best friend. If we're talking about graphing dots or graphing things on the XY axis, then graph the thing on the XY axis. If we're talking about inequalities, then I'm looking for the inequality or the range from 3 to 7. So interval notation sometimes gets confused with graphing dots on the XY axis or the Cartesian coordinate plane. It's just how it goes. One quick little note about the parentheses. If you're going off into infinity or going off towards negative infinity, you always give parentheses to the infinities. So kind of your process for this one is you have your lowest number, then you put a comma, and you put your highest number. And then you put whatever you're supposed to on the end based on whether it's an open or closed circle or an arrow. So open circle and arrows get parentheses. So open circles arrows. And if you have a closed circle, then you get brackets. Okay, so let's look at our examples here. We've got a number line, and it's going, my smallest number, I don't have one, I have an arrow. So that would be negative infinity. My biggest number is 3. I can never get to infinity, and I have an open circle at 3, so that's going to get a parenthesis as well. Practicing infinities, it's basically an 8 but sideways. So if you haven't drawn many infinities, so 8 goes like this. Infinity for me goes loopy, loopy. Like I'm trying to draw a fish, but then close the loopy. I've seen people do that. I've seen people draw 2 circles right next to each other. That to me is how I start drawing a face, so that's not usually what I do when I'm drawing infinity. So I go loopy, loopy. However you want to draw your 2 loopies, they just have to go next to each other instead of on top of each other. Okay, moving on. We have our smallest number is an arrow, so negative infinity. Our biggest number is 3. Infinities always get parentheses. We have a closed circle, so we're going to put a closed bracket on that guy. Here, our smallest number is 3. Our biggest number is arrow, so that would be a positive infinity. We don't actually get to the 3. We have an open circle on that. And then we have infinities always get an open circle. Smallest number is 3. I'm looking over here. And my biggest number is an arrow, so that's an infinity. I actually have a closed circle, which means I actually want to include the 3. And we can never actually get to infinity, so we're going to put a parenthesis there. And that's the basics of how set and interval notation work. Set and interval notation are going to come up for the rest of the term. They're also going to come up most likely in calculus. So you need to put this into some sort of long-term memory box so that you can remember this in a couple of months, in a year. This is going to kind of keep coming back up in mathematics and when we're representing various things. Okay, so now we're going to talk about kind of more complex inequalities. When you have a complex inequality, it's where you've got 2 different inequalities and you're putting them together. You end up with 2 different cases. Either you've got 2 arrows pointing out away from each other, or you get something that looks like a bar of shading in between 2 numbers. If you have the entire number line shaded, that's all real numbers. So set notation for all real numbers is actually that goofy R thing. Remember, it's an R with an extra backbone. You can write out all real numbers. Actually, no, you can't, because this is set notation, and you have to write all real numbers. For interval notation, our smallest number is an arrow, our biggest number is an arrow, and we can never actually get to infinities. So we've got negative infinity to positive infinity, and parentheses on both of those. Set notation, so we're going to have curly bracket. You could also, I guess, write x such that x is a real number. That's a lot of writing. You could also write x such that in math speak, you would put this, you do a backwards E and then an R. That would be like how you would do this in like a 200 level college math class, or maybe a 300 level. But this works for this class. All right, so next one, we want x such that, and I want to look at each of these inequalities individually. So over the first one, I've got x is less than negative 7. And over here, I have x is greater than or equal to 2. Yeah, so then I'm going to put those x is less than negative 7, or x is greater than or equal to 2. That's how we would set notation that. We would say or. We don't want to say and, because there's no number that is less than negative 7 and bigger than positive 2. Like, that doesn't exist. So we have to make sure we put or in there. If we don't put the or in there, it gets ambiguous, and we don't like ambiguous. We don't like confusing. We don't like people to be able to go, maybe it means this, maybe it means that. I don't know. So we want to put the or in there so people know for sure this one or that one, both of those numbers are the ones that we're looking for. Interval notation, we have 2 different intervals. The first interval has an arrow as the lowest number, and then a negative 7 is the biggest number with an open circle. So we put a parenthesis. Our second interval starts at 2. So I'm going to put a square bracket. I'm going to go to positive infinity because there's an arrow. In interval notation, how we say, hey, there's two different sections and we want to look at both of them, we put a horseshoe in between them, or a U without a tail. It represents union, and I don't really want to get into more detail than that. There's higher level math stuff going on with that particular symbol. It's a horseshoe. And that's just the U-shape horseshoe thing, a U without a tail, however you want to think about that, but that's what goes in between those two pieces. Okay, let's talk about this next one. Here, I kind of like these better for set and interval notation because I don't have to write out two different pieces. I want x to be bigger than -4 and smaller than 0, and I don't want to include either of those numbers. So for interval notation, I would say x such that -4 is less than x is less than 0. And that's all I've got to do. For my interval notation, my interval goes from -4 to 0, and I don't actually include either number. I'm not actually getting to either of those numbers. I don't have a filled in circle at either of those numbers, so I'm going to put parentheses. And then here, I'm going -1 is less than x is less than 8, and I'm actually have a closed in circle on -1, so I want that to be less than or equal to. So curly bracket x, vertical bar, -1 less than or equal to x less than 8. How you English this is you say, I'm looking for the set of all numbers x such that -1 is less than x is less than 8. That's how you would English that particular grouping of symbols. And then we're going from -1 to, I almost wrote an infinity, +8. And I want to get to -1, but I am not going to include 8. So how I think of these guys is if you have these ones, there's nothing extra, so you end up with an open circle and you end up with a parenthesis. If you add on the little guys on the bottom, you add a little bit of extra inside here, or you add a little bit to the top and the bottom of your parenthesis to turn it into a square bracket. So that's kind of my, like, the little note card in my head that I pull up whenever I'm dealing with these and I'm trying to figure out, okay, how do I graph these? How do I write them? And those kinds of things. Okay, whew, that was a lot on notation. So now let's talk about solving. Yay! Okay, so we're going to treat these like linear equations. The only exception when you're dealing with these guys is that if you multiply or divide both sides of the equation by a negative number, you have to remember to flip the sign over and go the other way. So let's just get going here. -12x plus 6 minus 4x is less than 90. Miss Norton, you just multiplied by a -3. Yes, I multiplied some things by -3. I did not multiply the entire inequality by -3, so no flippy the bar. This becomes -8x is less than 84, right? Oh, no, that's -20. No, -16. I can't add or subtract today. Okay, there we go. Then we divide both sides by -16. Now we flip over the thing because we divided both sides by a negative number. This becomes x. I'm going to guess that that turns into 4. -4. Okay, so I've solved it. Now I need to graph it. Shoop. Ba-ding, ba-ding. Okay, there's some people that are really fixated on the fact that you need to put a 0, then a -1, a -2, a -3, and then a -4. You can totally do that. Personally, when I'm graphing things, I only put the interesting numbers on there. I don't care about the rest of this. I just care about -4. And I want an open circle, and I want x to go that way. I want it to be bigger. And that's all I do. And then I want set notation. Oh, that's easy. X such that x is bigger than -4 with some curly brackets. And then interval notation, I start at -4. I've got an arrow for my bigger number, and I don't include either of those because I don't actually get to either of them. I don't remember why I put these other ones here. I'm going to go ahead and do this bottom one down here really quickly. I'm just curious if I put them here for a reason. I might have. I think I did, actually. Of course I did. Of course I put them here for a reason, but what was the reason? 40 minus 16x is greater than -16x plus 40. Wrong. Shenanigans. So I can subtract 40 from both sides, and I have -16x is greater than negative 16x. And then I can subtract or add 16x to both sides, and I end up with 0 is bigger than 0. Can anything be bigger than itself? No. It can be bigger, it can be equal to itself, but I cannot be bigger than myself. I'm not smaller than myself. Numbers can't be bigger than themselves. 0 is not bigger than 0. So this is no solution. So if you were going to graph it, it would just look like this with no shading. And then this is set notation and also interval notation. There's no solution. So I'm going to guess that this one is going to lead us to an all real number situation. So let's get that guy out of the way. Negative 2, nope, 8x. Let's make this a little bit smaller. Negative 8x minus 2 is greater than or equal to negative 8x minus 2. Hey, looky there. So can add 8x to both sides and get rid of the x's. You can add negative 2 or add 2 to both sides, get rid of the negative 2's. Is 0 less than or equal to 0? The answer is yes. 0 is less than or equal to 0. This would work even if you ended up with something, sorry, I should leave that example alone. If you ended up with something like 4 is greater than 7, that's false. But if you ended up with 4 is greater than 0, that's true. So those are other ways that it doesn't always end up with 0 is greater than 0 or something like that. Sometimes you have different numbers, and that's perfectly fine. So what this guy looks like on a number line, shade it all, shade it all, everything gets shaded, everything is real numbers. That's what the answer is. So set notation is all real numbers, our beautiful little thing. That is a perfectly valid thing. Our smallest number is negative infinity, our biggest number is positive infinity, and we put parentheses on it and move on with life. So I should probably like, wait. Okay, now I can go on. Woohoo! Now we're going to talk about solving absolute value equations. Yeah, this one's going to go a little bit longer than the previous two. First thing you do is you always get the absolute value by itself, pretend like it's the ginormous variable, and then we have to split the inequality, just like we did with absolute value equations. We're going to split absolute value inequalities, and then we're going to solve both of the pieces. And I hope I left myself enough space here. We shall see. X plus 3 is less than or equal to positive 4. Absolute value. And so for this one, you split it into two pieces. So you have the inside is less than or equal to the positive version, and you have the inside is greater than or equal to the negative version. So what we're doing here with the split is this is everything the same, all the same. For this one, you change the sign and the inequality, which is the other sign. Change the signs, I guess. Change the positive, negative, and the badoop. So whichever one you're changing there. I hope that made sense. X is less than or equal to 1. And x is greater than or equal to negative 7. The reason why we always do these on a number line first is because then we figure out whether or not we've got two things that are pointing towards each other or two things that are pointing away from each other. And so we're going to throw this on a number line. Badoop, badoop. Here's 1. Here is negative 7. 1, I want x to be less than 1. And I want less to be greater than negative 7. So I'm actually going to and fill in the stuff in between. So set notation, I want x such that my smallest number is negative 7, less than or equal to x, less than or equal to 1. And for interval notation, negative 7, positive 1, square brackets on both. And that's pretty much how these guys work out. Let's see. Let's do this next one. Here we would add 5 to both sides. So 9 times the absolute value of 10 plus 6x is less than or equal to 72. Dividing both sides by 9, we have the absolute value of 2 plus 6x is less than 8. Splitting that up, we have 2 plus 6x is less than 8. And we have 2 plus 6x is greater than 8. So 6x is less than 6. Oops, negative 8. And x is less than 1. 6x is greater than negative 10. X is greater than negative 5/3. 1, oops, negative 5/3. 1, open circle, less than 1, bigger than 5/3. Same type of setup, just with open circles. So we end up with x such that negative 5/3 is less than x is less than 1. And negative 5/3, 1, parentheses. All right, last but not least, we have absolute value of 3 minus 3x is greater than, oh dear, 120 divided by 8. I don't know. What is 120 divided by 8? I can go into that once. That gives me 40, which would be 15. Okay. And so now that gives me 3 minus 3x is greater than 15. And 3 minus 3x is less than negative 15. Okay. So negative 3x is greater than, that would become 12. Divide both sides by negative 3. And we've got x's, flip the sign, less than negative 4. And doing the same over here. The 3 moves over there. That becomes negative 18. X is greater than 6. All right, number line. Here's the negative 4. Here's the 6. Open circle, open circle. I'm going to go x is less than negative 4. And x is bigger than positive 6. So we end up with one of those complicated ones where x is less than negative 4 or x is greater than 6. And we go negative infinity, negative 4, open parentheses on both, horseshoe thing, positive 6, positive infinity, and we don't get to either of those as well. And we're done. Yay! That's that. If you had questions, please make sure you keep track of the timestamp of the question and then send me the question, let me know what it was. I'll be more than happy to help you out with that. When you move a negative number from one side of the inequality to the other with multiplication or division, remember to turn the inequality sign the other say around. And with absolute value inequalities, pay careful attention to when you split the inequality to make sure, like there were a couple of times where I almost forgot to put the negative on the second version, or I forgot to flip the sign on the second version. So make sure you do both of those things, negative to positive or positive to negative, and also greater than to less than, that whole thing. This is the end of Unit 1. We'll have to see what comes next. Look through your notes, make sure that this all makes sense. If it doesn't, rewatch. And as always, make sure you fill out that video reflection form and have a wonderful rest of your day. Happy mathing!